A 1 meter long, 200-gram rod is hinged at one end and connected to a wall. It is held out horizontally and then released. What is the speed of the tip of the rod as it hits the wall? Okay, so we're going to have a before and after picture. So before we have this case here. So we have this wall. This is my before. This is my center of mass. And we have an after. This is my center of mass. And we're saying that this location is y equals 0. And this location here is negative L over 2. We're trying to find the speed. So we're trying to find the speed v final. So we have our givens and finds here. So we have, I'm not going to write them because they're given right here. This is our before. We have our center of mass is 0, our omega is 0, and our mass is 0.2. And then after we have our center of mass here is L over 2. And we're trying to find V at the tip. So we're trying to find V right at the tip when it hits the wall. Okay, so we're going to start here, and we're going to write right under here that our K initial plus U initial is equal to K final plus U final. We can also do our free body or our energy bar chart. So we can say, okay, we're going to have K initial plus U initial is equal to K final plus U final. So initial. And if we notice here, because the right here, when we start, our y of the center of mass is at 0, we have no potential energy. And then our bar is not moving in the before position, so we have no kinetic energy. So this is going to equal 0 on this side. And now what about on the right here? Well, we know that our we're going to have kinetic energy, and we're going to have no potential energy. Or we're going to have some potential energy because this is y equals 0, actually. This is our y equals 0, and now we're going down to negative L over 2. So we're going to have both of these terms. So we're going to have a negative. So let's see if I can just move that over a bit. So we're going to have a positive kinetic energy and a negative potential energy. And these are going to cancel. So this is my U final here. And they're going to cancel because we need 0 kinetic. We need that to be equal to 0 mechanical energy on the left-hand side. So here we're going to have 0 is equal to our kinetic energy final is going to be 1/2 I omega squared. That's our rotational energy because our rod is just rotating about this point right here. Plus our U final is going to be equal to mg y final for the center of mass. Let's see. So we know that I for a bar that's rotating about its end is equal to 1/3 mL squared. And we also know that our y final center mass is equal to a negative 1/2 L. So if we're going to plug these in, we'll have 0 is equal to 1/2. Have a little snafu there. So it's going to be 1/2 L. Okay, so we plug that in, so we're going to have 0. Let's move this over. Let's go back here. We're going to have 0 is equal to 1/2. And if I plug in 1/3 mL squared times omega squared plus mg and negative L over 2 So 0 is equal to 1/6 ml squared omega squared minus 1/2 mgl. And so I'm going to bring my 1/6 ml squared omega squared. I'm going to bring that, I'm going to keep that over here, and I'm going to bring this to the other side. So I'm going to add 1/2 mgl to both sides. So I get is equal to 1/2 mgl. My m's cancel. I'm looking for omega. So one of the L here cancels with one of the L's here. I can multiply through by 6. So I'm going to have omega squared L is equal to 6 over 2 times G. I can divide by L. Times 1 over L. So omega squared is equal to 6G over 2L. So omega is equal to 3G over L square root. So when I plug numbers in, I get omega is equal to 3 times 9.8 meters per second squared divided by 1 meter. And when I do the math, I get 5.4 radians per second. And now I'm not looking for omega final. It's on the way to finding my V final. And so we're going to use this equation that V final is equal to omega times L. So V final is equal to omega L. So plugging in, we get V final is equal to 5.4 radians per second times 1 meter. So V final is equal to 5.4 meters per second. And that's how fast the tip here hits the wall. And so what we did in the problem is we calculated the omega, the angular velocity for the center of mass here. And we know that the angular velocity for the center of mass is the same as the angular velocity of the tip of my rod. So the angle is the same regardless. If you think about this rod moving down, the angle is going to be the same, but the velocity is omega times r. So my velocity at the tip is going to be bigger than my velocity at the center of mass. And so that's why we needed to multiply by L, the length of the rod, to find the velocity at the tip.